All right, so today we're going to jump into section 8.2, which is looking at measures of dispersion. So we're going to keep going in this statistics train and really just talk about a pretty important topic, actually, standard deviation and our variance. So let me go ahead and switch over to the notes here. And the very first thing that we need to know is, when we're talking about measures of dispersion, we're trying to understand the characteristics of the data set that we're looking at. Okay, so if you've got a data set that's really, really kind of stretched thin and pretty wide, like a wide data set, then your standard deviation, how far apart the mean is from each of your data points, is going to be fairly large, right? If you have a smaller one, a smaller standard deviation, then the data is going to be nicely clustered together. And this is really important when you're looking at research. If anyone ever digs into journal articles or research, if you see that there's data presented with really large standard deviations, it means that you have a lot of spread out data, and that might not be a good thing depending on what you're studying or what you're looking at. And so really, these are all, again, all these numbers do is they just give us information about what's happening. It may be good, it may be bad, depending on the circumstance, but it just gives us information. And that, I think, is very valuable when you're analyzing and looking at statistics as a whole. So the first thing that we're going to be looking at is the range. This is just a very baseline look at the smallest value to the largest value, right? The difference between the biggest number and the smallest number. How big is that gap? We will go through a definition here, or an example just to go through it, but I kind of already talked a little bit about the standard deviation, but this is a really good graphical way of representing it. So we'll talk about distributions in, I think, a lesson or two, but the one thing that I really want to emphasize is, again, that spread outness. That's not even really a word, but I hope you get my point, right? How clustered or how far apart is the data? And so you have your mean here. This is typically like, we'll look at standard distributions or a normal distribution also is what they're called a little bit later, I think in either the next section or the section after. But when you have a normal distribution, your mean is going to sit right in the middle. And the sigma here, that's the Greek letter sigma, that represents the standard distribution, or the standard deviation. So the standard deviation is how far apart these data are clustered. So you can kind of see this one has a little bit more of a peak to it, but it's really kind of tightly clustered together. That means, as a result, we have a smaller standard deviation. So let's take a look at what we have here. I kind of wrote that wrong. I'll have to fix that. Mu is the population mean. The standard deviation is going to be our sigma. Here we've got the formulas for what those are. And I'll just be honest with you right now. It's a lot of calculation, and I'm going to show you a few tools that are going to really speed up the process of calculating these values. Because I'm more interested in you understanding the concepts of these things versus just having to sit down and spend 20 minutes calculating stuff, right? Like, obviously there's a skill involved, but there are some tools that we have that are really, really useful. I'm going to show you a tool with the TI-84 as well as a standard spreadsheet. So you can use Google Sheets or Excel to work through a lot of this stuff very, very, very quickly. And so that's what we'll go ahead and do. But for our standard deviation, again, it's this Greek letter sigma, and it's equal to each of the data points subtracting the mean and squaring each of those. It's the square root of all of that stuff divided by our number in the data set. Okay, so this is going to be our population standard deviation. Okay. The sample standard deviation is exactly the same thing. The only difference is we're just dividing by an n minus 1 instead of an n. And we're also using the sample mean. But practically speaking, they're basically the same thing. Okay, so I wrote out a procedure for you that you can use in case you get stuck. So I'd encourage you, if you have this document, which it's available on Canvas, I'll show you where that is here in just a minute. You can go ahead and download this thing and just follow along with these steps for finding the standard deviation. So we want to first figure out the mean of the data set. We're going to calculate the deviation or the difference from each specific data point, right? So it's between the data point and the mean, whatever that difference is. Then we're going to square each of those pieces. Then we sum those things up, and then we divide it by the either n for the population standard deviation or n minus 1 for the sample. Okay, so really that's all we're going to be doing in this. It's just a lot of very small mathematical operations, but we're just adding a whole bunch of them together. Okay, I will briefly mention the variance. This is more of a mathematical thing. Standard deviation is more commonly used in statistics, but variance is another measure of dispersion. And all it is, it's you take the standard deviation and you square it. So if sigma is the standard deviation of a population, sigma squared is just the variance. S is the standard deviation of a sample. S squared is the variance of that same sample. Okay. And again, I'll go through a couple of examples as we walk through them. So here is the first question that I want to look at. Let's go ahead and jump over to our Blackboard here. And so what I want to do is, this is like a nice kind of ease into it question. So number 1, during a 2-hour period on January 12th, 1911, the temperature dropped in Rapid City, South Dakota. So the temperature dropped. The location really isn't necessary, although I might not want to live in Rapid City, South Dakota, based on what I'm about to show you. It dropped from 49 degrees Fahrenheit to negative 13 degrees Fahrenheit. Good grief. 2-hour period? Holy cow. That's a lot of temperature change. So the question here is, what is the range? Okay. And all we have to do is take the difference. And when I say difference, we're subtracting. So we take the larger value and we subtract the smaller value. So in this instance, we have 49 degrees Fahrenheit, and we're going to subtract off a negative 13 degrees Fahrenheit. Whoops, let's put the Fahrenheit in here. And we just have to figure this out. So I'm subtracting a negative, which means I'm adding a positive. So this is going to be plus 13 degrees Fahrenheit. And as a result, 9 plus that is 2, plus 1, 62 degrees total, I believe, is the jump, or how far apart. So again, this is the range. So this is the range. In other words, it jumped, or I guess decreased by 62 degrees in the span of 2 hours. That's insane. But they must have had really bad weather, I'm assuming, like a crazy snowstorm come through. But in any case, this is how you compute the range. You take the large value and you just subtract the smaller value. Okay, and you can do this for any data set whatsoever. This next question that I want to jump into is really where we're going to start utilizing some of the technology, and so I want you to bear with me on this. I'm probably going to be jumping between some apps here, but I'm going to be using Google Sheets on this. You can use Microsoft Excel if you want and create your own formulas. I don't care. I have everything already established and placed in this Google Sheet. All you have to do is punch the numbers in, and it'll output all of the information you need regarding that data set. So that's part of the reason why I enjoy using Google Sheets, because it makes life so much easier when you're dealing with a slew of data. So on question number 2, this is really going to be a fuel efficiency problem. So over the span of a few days, fuel efficiency was measured on this vehicle, and these are the fuel efficiencies that we found. Okay, so fuel efficiency. Let's do, so we'll have 22 miles per gallon, 25 miles per gallon, 27 miles per gallon, 15 miles per gallon. They must have been slamming that accelerator on that one. 24, 24, 32, 23, 22, 25, 22. Now, again, we could do all of this by hand. I'm not going to do this because this is an absolute nightmare. But here's how you would do it. What you do is you set up like a T-table here, and you put in your data value, so 22, 25, right, etc. You'd punch in your x minus your x bar. So you'd have 22 minus whatever the mean is. Well, you'd have to figure out the mean. So the mean would be something else that you'd have to compute. So you'd sum all of these things up. 25 plus everything all the way out here. And then you divide by however many you get. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I skip one? I feel like I skipped one. 22, 25, 27, 15, 24, 24, 32, 23, 22, 25, 22. Oh, I guess so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why do I have 12 in that one? And did I count right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I missed one. What in the world? Sorry. Time out. Let me figure out what this problem is. Oh, I did miss one. Okay, it was the third one. My bad. Let's try this again. I was looking at it. I'm like, wait a minute. What the heck is going on here? All right, 25. There's supposed to be a 23 here. That's why. All right, now we're good. So, all right, there's 12 of these. That's the point. Okay, you're dividing by the total number. That's the sample mean. So in this instance, what we're going to do is we are going to compute this, whatever that is. So we subtract off our sample mean. And then we have to do this whole, whatever number we get here, square that. It's a lot, okay? It's a lot to write down. So here is what I'm going to do. I am going to switch over to, first off, the calculator, okay? And I'm going to calculate this in the calculator. So if you go to the TI-84, the way to do this is to click on this little stat button right here, okay? And then what you're going to do is you're going to edit your list. So that's option number 1. Now you'll notice I already put all of these in, but it really is as simple as just typing it and hitting enter once you're done with that particular row. We're only going to use L1 here. We're not going to use any of these other lists. So just this first row, or first column, I should say. So again, you type the number in, 22, hit enter, it'll jump to the next one, 25, hit enter, jump to the next one, 23, so on and so forth, right? So I already have the whole list here. To run the calculations that we're looking for, we're going to quit back out to the home page, and to do that, we hit second. This quit button is right here. It's the mode. So we hit second mode, and that just takes us right back to the home page. And now what we're going to do is we're going to go back to our stat. We're going to run calc. So scroll over to the right here to calc, and then choose option number 1, which in this case is 1 var stats. This is 1 variable stats. Hit enter. The list that we're using is L1. You don't need to worry about the next thing. just leave it blank, and then hit calculate, and all of this data will be given to you. So you'll get your mean right here, 23.6 repeating, or 23 2/3. You have the sum of all of the data points, which is 284. The sum of those data points squared. That's another very valuable statistic, but we're not going to really dig into it. Again, we're just going to focus on the standard deviation today. This right here is the sample standard deviation. So it's 3.91. The population standard deviation is a little bit smaller. The number of items in our data set, the minimum value, and you can see there's a little bit more information presented. Minimum data value, the median, and the max data value. The Q1 and Q3 are quartiles. So at the 25% mark, that would be 22. At the 75% mark, that would be 25, the data point. So again, these are it's just valuable information you can glean from all of this. But really, we're just going to focus mostly on these numbers. So in this instance, if I'm looking for a sample standard deviation, right, 3.91 is going to be my sample standard deviation. Let me go back to my blackboard here. Here we go. My S is going to equal 3.91. Okay, that's my standard deviation. All right, so what I want to do now is, that's, again, going back to the calculator, this is the process that you use. So any data set that you have, you're going to enter it into the edit. So you click the stats and then edit, and then run through those. Just punch them in as you see them. And then you can use the tool stat calculate and run the one variable statistics to get the answers. Okay, the variables, the variables and the numerical values. Good grief. Woo. So if you go to Canvas, what you'll notice is in Canvas, if you scroll down, I have all of basically everything listed on a week by week basis, right? So scroll down to the week that we're on, and you'll notice I've got the Google Sheet with formulas listed right there. And if you click it, it'll download a copy and give it to you for free. I'm not going to click this because I already have it open over here. So I'm going to open this thing up, and you'll notice this is the first page is 4.4, which is, we already went through all that content a while back. The one that I really want to focus on is 8.1 to 8.5, and this is like if I have a problem. Again, you can edit all of these data values right here. Don't touch anything that's this column over, because these are all formulas that are just automatically put in there. And you'll notice I've got the, it'll freak out when you delete everything. It's fine, don't worry about it. This right here will give you the data minus the mean, the data minus the mean squared, the z-score, which we haven't talked about, well, that'll be the next section, and then the mean, which is calculated right here. So what I'm going to do is I'm going to punch these in, these data values, and they should pop up. So we're going to use the same data values that we used in the problem for the in the calculator. So in this case, it's 22, 25, and you can start to see that things are starting to fill in now. 23, 27, all these numbers are going to keep changing as I add more entries in. 24, 24, 32, 23, 22, 25, and 22 is the last one. I'll work on adding more for the items over here, but don't worry about that for now. So I've got these data values, okay? And over here on the right-hand side, I've got the mean. I've got the sum of squares. Again, it's that value that we talked about earlier. Don't worry about it. It's basically the sum of all of these things right here. We'll get into that in a little bit. The sample variance. I don't know if I'm zoomed out a little bit. Let me zoom in here. This might help in case you're having difficulty seeing it. The sample variance is something, unfortunately, that the TI-84 does not give us. And so that actually comes from the sum of squares, which is before that. So you can calculate what that is. But the sample standard deviation, that is the thing that we're looking for. Now, there's actually a few different ways to calculate that in Excel. One way is to use all of these pieces that I put together. And I did this kind of just on my own. I thought it would be helpful. There is an actual function built into Excel and Google Sheets that is to figure out what the sample standard deviation is. And all you have to do is compute what these values are, and it will do that. So sorry, I just edited that formula while I was in here. But all you have to do when you're working through this sheet, don't touch any of this stuff over here. All you need to do is just move or edit these things right here, and you'll figure it out. So again, I just wanted to kind of walk you through that to see what that specifically looks like. So if we go into, say, the homework, okay, and I'm going to log in here. I'll do a homework problem with you. Yeah, okay. Pause for a second. I have to sign in. Okay, so we're in here in the homework, and I'm going to zoom in on this a little bit so you can see it better. But here's like a quick question. This is like one of the homework questions that I do want to walk through. So a survey of 10 fast food restaurants noted the number of calories in a mid-sized hamburger. The results are given below. And what we need to do is find the mean and the sample standard deviation, round to the nearest hundredth. So that's 2 decimal places, okay? Sorry, 2. I gotta put my fingers up here. 2 decimal places. So we have these data points here. And what I'm gonna do is I'm just gonna pump these numbers into the data sheet, and sometimes it's a little handy to have, like, let me pull this out here. Oh, my screen froze. Having so many technical issues today. Holy cow. My computer is not having a good time. All right, after resetting my browser and coming back, what I was trying to do is split my browser into 2 windows side by side, so that way I can see these and just punch these data values in. And so basically what we have is I've got 514. Here, let's clear all these out. So if you clear all these, basically highlight all those numbers, delete them. There we go. And don't worry about these errors. I'll actually fix that when you're working on it, so it won't create problems. 503, 498, 495, 505, 459, 479, 464, 514. Okay. So I'm going to delete these really quick because they're irrelevant. Don't worry, I'll fix all this. So what we need to go ahead and do is, again, this will compute the mean. So right here, we've got the mean. It's just the average over the number of values that we have, the sum of our squares, the sample variance, and the standard deviation of our data set. So that right there is the 2 questions that we need, 493.90. Actually, let me see. I might need to go out more. Oh, it is 90. Nice. All right, so 493.9, that's going to be my mean. 493.9, and then the sample standard deviation. I swear, I really hope I'm right in these. I have not tested this, so we're doing it live. 90. I'm going to put 90 in there just in case. Submit answers. Yay, look at that. We got it. I love it. So again, you can use this data sheet to your desire as much as you want. Again, I would recommend avoiding to edit this stuff that's beyond the left-hand column here. And so just enter in your data points here, and then you'll get all of your all of the stuff there. So you should be good. But that's all I have for today. And if you have any questions, feel free to let me know. But I hope this was helpful. And, as you start to work more in spreadsheets, you'll probably find, I know this is going to sound really stupid. This is how you know I'm a total nerd. I love spreadsheets. They're amazing. They help so much with just simplifying really complex processes. And so if you have to do a lot of really simple tasks quickly, go to a spreadsheet. So that's my soapbox. We'll be seeing you. Have a good one.